Well, greetings, Mr. Kolazar's class. We're going to start into section 6.6 in your notes. We're going to be looking at today trends of the periodic table. And what we're going to look at with trends is going to be as one thing changes, how does something else change? And so we're going to use this to kind of relate some ideas of the PT coming up. So our first trend that we're going to look at is, first one, adding energy levels happens as we go down a group on the periodic table. So as we go down a group, from period 1 to 2 to 3, 4, 5, 6, 7. As we go down from period 1 through 7, we're going to increase the electron's distance from the nucleus, which makes the atom size increase. So to draw a picture of this out, a little picture in period R for the first one, as we add an energy level around the nucleus, each time we add an energy level, our atom gets bigger. Each time we add an energy level, it's going to get bigger and bigger. So size-wise, each energy level that we add is further from the nucleus, which increases the atom size. So more energy levels, we have larger atoms. Our second factor then is going to deal with what we call electron shielding. Electron shielding, we're going to focus again on those valence outer electrons, is going to be a decrease in attraction between the outer electrons and the nucleus. The inner or the core electrons, as we'll call them, shield the attraction of the nucleus for the valence electrons. So our second picture for electron shielding, so we're just going to draw this in underneath number 2 in the slide, is if we were to say this is the nucleus, and this was going to be each level around the nucleus, the inner electrons, the positive and negative, are attracted to each other. But the further away, these electrons are going to partially repel, so these are going to be less attracted to the nucleus. And the further out electrons in the next outer energy level are going to be even less attracted to the nucleus. So the further out the electrons are, energy level 1, energy level 2, energy level 3, and it goes on. Every time we go further away from the nucleus, these electrons shield the attraction of the nucleus to the outer energy level. So the core electrons, the electrons in the inner levels, are going to shield or make these ones even less attracted to the nucleus. And our third factor is going to be called nuclear charge. Now, nuclear charge happens when you go across the periodic table. So when we go from left to right. So as you go across the periodic table, there's an increase in charge from the nucleus as more protons are added. So as we move across the periodic table, we add more protons. And you get more of those as you go across the periodic table. And all of those protons are going to pull on the electrons to attract them. This is a key idea to remember. Remember the 4 P's. Add in across the period, more protons, more pulling power. So this is our 4 P's to remember. So what we're looking at is nuclear charge. Increase of the nucleus, or increase the pull from the nucleus as more protons are added. So think about this in strength of numbers. If we have 1 proton, it's going to pull on the electron. If we have 2 protons, we get more pull. Make sure we draw these 2 ideas in that space below number 3. We have more proton pulling power, so each of these electrons are going to be pulled to both of these protons, and they're going to be held tighter. So the more protons we have, they pull on each individual electron, and that causes us to get a stronger attraction or a stronger nuclear charge to each one. Now we're going to use these factors to look at the other trends of the periodic table coming up.